This lesson requires a lot of writing because they want us to write story problems or word problems based on the information that is given, and then after that, we also need to solve the equation for all the missing information. So, right here, it says to write a word problem to go with the information. So there usually should be a sentence for each of the unknowns and the equation. So, for example, this one we have this A for Allie, and then this tells us Mel's age, and then we got this equation right here. So each of these should produce some kind of sentence, and if it's just a letter like it is for Allie, Allie equals A, that should be the question, because A is also in Mel's age, and it's also in the equation. So when we solve the equation, we would solve for A, which is Allie's age. Therefore, we should write a question for these. For good old Allie's age. Let's get ourselves, there we go. So Allie, oh, this is the question part. So, how old is Allie? Question mark. Alright? Because once we find Allie's age, we can find Mel's age as well. Now up in here, we can see it talks about Mel's age. So let's look at that. It's 2 times A, so Mel is twice Allie's age. But then, right, they subtracted 3. So let's say Mel is twice Allie's age, or just minus 3 years. I look at these. There we go, years. Okay? So that's 2 sentences, one for Allie's age, one for Mel's age, and then finally we need a sentence to go with the equation. And that one, the equation, it shows A plus 2A minus 3, and the 2A minus 3 is Mel's age. So the sum of their ages, and that's sum because it's adding, the sum of their ages is, right there it shows us 39er. Bam, so we'll write 39 years. And we already have our question, how old is Allie? So this would be the word problem that would be fitting for these. And then we just need to solve the equation. So, actually I'll move this garbage over. Let us solve the equation. Now again, when we solve this equation, we will have the value of A, which is Allie's age, but we'll still need to find Mel's age. Alright, in solving this equation, we got this 1A, so we'll combine it with these 2 A's, giving us 3 A's. We got minus 3 equals 39er. Then we'll add 3 to both sides. So 3A equals 42. And then divide both sides by 3. And we see that A is 14. Now again, we can't leave it like this because this is a word problem. So we got to look at the wording on it, these, and let's give ourselves some more wordings. Just for the answer part. So right here, we see that Allie is 14 years old. And Mel is twice Allie's age. So that's 2 times 14, which is 28. And then minus 3. 25, right? Mel is 25 years old. Bam. And that would be the whole problem for these. Because we have our word problem, we solved the equation, and we found all the missing information. Alright. On this problem, we've been given the 2 angles. And like I just told the other classes, okay, we got to write at least a sentence for each of these parts. For example, they gave us S, which is the small angle, so we should have a sentence for these. We got 4s for the larger angle, so we should have a sentence for these. And then we got an equation, so we should have a sentence for these. Now on these, we can see that the larger angle is 4 times s, which means that it's related to that smaller angle. The equation has only one variable, s, which is good, which means we're solving for s. Therefore, when we write the sentence for s, it really should be more like a question. So we will write, how many degrees is the small angle up in here? And a question mark is very nice. Next up, we got that 4s. Well, that one's pretty easy to write out because it's the larger angle. So the large angle is 4 times
Wait, where are we writing this?
as big. Yeah, just write on the paper.
On the first square or the second?
Yeah, the first. The large angle is 4 times as big as the small angle. And then we got the equation sentence up in here. And that is, we can see that we got the sum, because it's addition, of the small angle combined with the large angle equals 70 degrees. So we'll write this one out as well. There we go. The sum of the two angles is 70 degrees.
Is this still in the first box?
Yep. All right. It did ask us to solve for all of the unknowns, and right now the unknowns are the small angle and the large angle. But if we solve the equation, then we will have solved for s, which is the measurement of the small angle. So that's a 1s, by the way. Some people kind of forget that. So when I combine my s's, I've got 5 of these s's, equals 70 degrees. Now when I divide both sides by 5, I get that the small angle is 14. And that would be 14 degrees. We should write that out up and count. This is the small angle. The small angle.
You say angle or ankle? This is not.
That's what I said. Degrees.
Good job, Mr.
Thank you. Hey, us math people know how to spell sometimes. Well, the small angle is 14 degrees. Then how big is the larger angle? Well, it'd be 14 times 4, right? Because it's 4 times as big. 4 times 14, bam, 56 degrees. Is the measure, because we should, it's supposed to be in sentences, of the large angle. There it is. That's it. And that's all we would need to write for this problem, because we solved for both unknowns, and we wrote pretty much a story problem, and it's it's very entertaining. Here we have the width of a rectangle, W, and then we got 2W plus 3 equals the length of a rectangle. So if we look at these, we have our width, which is just W. That's very convenient. And then the length is this 2W plus a 3. And we can find that all over in this equation, right? We got this W, and then 2W plus 3, and then this other W, and then this other 2W plus 3. Well, 2W plus 3 is the length, right? So if we looked at this in a different way, we really have width plus length. That's a plus. Plus width plus length, right? Equals 78. Now this shape right here is a rectangle. Now if you take the width plus the length plus the width plus the length of a rectangle, what are you actually finding?
The perimeter.
The perimeter here, okay? So we know when we make the equation, when we write the sentence for the equation, that it's actually the perimeter. And I could be spelling this wrong, but that's okay. All right? So we got three sentences that we will need. One for the width, one for the length, and one for the perimeter. Which of these three will be the question? What is W? Well, more specifically, what is the width? Very good. So we'll want to specify that in our sentence. Starting with the width. What is the width? And we can be more specific of the rectangle. Okay, so that takes care of the width right here. Next up, we have the length, which tells us it's 2W plus 3. So the length, we'll say, the length is twice. Does everyone understand why it's twice?
Yeah.
Twice the width. Twice the width plus 3. Now there's a lot of ways we could say that right there. The length is 3 more than twice the width. It's twice the width and then 3 more. However you want to word that, they're all the same, okay? So there are different ways to word these. Next up is the equation. Now we know the equation represents the perimeter, so we'll say the perimeter, oh yeah, okay, we're good. Perimeter of the rectangle, that's spelled wrong, but it's close. The perimeter of the rectangle is, and it shows there it equals 78, and it looks like that's in inches. 78 inches. Bam. We could have said that the sum of the width and lengths and then another width and length would be 78. So you don't necessarily have to know that's the perimeter. We can specify that otherwise, but it's good to know that it is the perimeter because it means that we don't have to write as much. And since this is math, well, we don't really like writing, do we? Now that we have that, let's go ahead and solve the equation, all right? So in solving this equation, we don't really need the parentheses there, so we could just put W plus 2W plus 3. And right here, I would just be looking to combine like terms. I got this W, that's a 1W, plus this 2W's, plus this 1W right here, and these 2W's. So when I combine all of them, I should get 6 of these W's. Now I still got this 3 and this 3, which when I combine with these, I get a positive 6. This should equal 78. Well, from right here, I would be subtracting 6 from both sides. So that I got 6W equals 72. And to solve with these, we'll divide both sides by 6. And we see that W equals 12. Now again, this is a word problem, so we can't just leave it like this. We need to explain what it is. So right now we can say the width is 12 inches. But we still need to find the length, right? So the length, which was shown as 2W plus 3. This is the length. But we already know the W, the width, is 12 inches. So we'll just solve this. 2 times 12 is 24 plus 3. Bam, 27 inches is the length. And we'll write that in as well. The length is, what do we get? 27 inches, right?
Yeah.
27 inches. That's it. We got it. All right. Well, we got Vicky's money is V, and 5V is good old Wally's money. Then they gave us the equation, 5V plus V equals 72. And yes, we do need a sentence for all three of these. So let us write a sentence for these. So V, right here. Let's go ahead and write us a sentence. Yes, what could we write? Yeah?
Me? You could write that Vicky's money is V, and Wally's money is 5 times Vicky's.
Okay. Now, Vicky's money is just V though, right? So that should be included in the question, right? Because we're not doing anything.
I did it. I included
V.
it into the question.
It sounded like it was more of a
I said Vicky's
statement.
money is V, and Molly's money is 5 times Vicky's money.
That sounds like a statement to me. So, let's rephrase it into a question. Yes? That works. How much monies does Vicky has? Alright, so that's that part. What about good old Wally? Wally is 5V, so let's go ahead and write a sentence for Wally. Maybe it's Wallace. I don't know. Alright, someone have that for us? Yeah?
Molly has 5 times more money than Vicky.
Very good. 5 times more monies than Vicky. Bam. And then the equation as well, right? We need to write a sentence for the equation. 5V plus V equals 72. So what do you guys got on at these? Anyone got? Yeah?
Vicky has Wally has 5 times the amount of Vicky, plus Vicky's money is 72.
Let's make sure. Vicky's money plus Vicky's is 72?
Yeah.
72 bucks. Yeah, that would work. That seems to describe the equation to me. Perhaps you said together they have $72, or the sum of their monies is 72 bucks. You know, something to that effect would work as well. Well, now that we have that, let us solve these. So, we'll make that a 1V, right? So what do we do first, Brad Count? Yeah? Correct. Combine the variables. Well, if I had 5 V's and 1 V's, how many V's would I have?
6 V's.
6 of these V's, which now equals 72 bucks. So what would we do now to solve? Yeah?
Subtract 6 from 6V.
That's close. See, if we subtract 6, it makes a 0, right? Well, we want a 1V out of this thing, right? So, yeah, Kennedy?
Divide.
Bam, divide by
6.
6. Yeah, so 6 divided by 6 will give us the 1. 1V equals 72 divided by 6. Bam, 12. Now, again, there's a word problem. So we could say Vicky has $12. $12 for Vic, because it's shorter. Well, Vicky has 12 bucks. Then what about old Wally?
Molly has 6.
Wally has 72 minus the 12. Bam, yep, 60 bucks. So we got our 2 answers. We got sentences for our story, and we're good to go. So that is how you would check that, right? You do 72 minus 12, that's 60 bucks. And then 12 times 5, which is Wally's money, is also 60 bucks. Here we go. Number 5. Here we got the number of red marbles. And then we got this, they spelt that wrong, it's perverted purple.
No, it's not.
And we got 3M of those. They spelt it wrong, it's perverted purple, not that's what they spelled.
It's like that.
No,
Your
it's
mistake is
black.
not like
There are
blue.
blues because they're just better.
Yeah, no, okay. Well,
I have a headache.
I need to write an equation for these. So we got 2M, and then plus 3M equals 155, right down here. That's the equation. So we can see that 2M and 3M is the number of marbles. M is some number of marbles, I guess.
155.
M is just some value, which we don't know from the story problem. So we may have to make that up. M may be, let's write that in actually. M can be some number of black marbles, because I'm going to use black. So we'll write that in. How many black marbles? We'll use appropriate M. Are there?
There's no black marbles.
Well, it doesn't talk about black marbles. But that doesn't mean there aren't any.
No, it says not. There's no black marbles.
Yes. Now, what I did there is I created a value of M so that we can compare it with something else, okay? So what they did right there at the bottom, how many black marbles are there? Well, the red ones, which we should write about, by the way. So the number of red marbles, there are twice as many reds as black marbles. And then we got the perverted purple ones. There are 3 times as many perverted purple marbles as black marbles. Okay? But then, in addition to these, we have the equation, which shows that the sum, because it's addition, of the 2m, which is the red marbles, the 3m is the perverted purple marbles, the sum of red and perverted purple marbles is 155 marbles. Bam. That's pretty good. That's really nice right there. So we've written out the story problem. Now what we must do is solve it. So when I solve for m now, and we just created that part, right? We'll figure out how many black marbles there are, which will in turn allow us to figure out how many red marbles and then perverted purple ones. So I could combine my m's. 2 m's and 3 m's would give us 5 m's, which equals 155. Now when I divide both sides by 5, again this will tell us how many black marbles there be. So the 5's cancel out, and this looks to be 31. Okay, but we're not finished.
We're not.
We isn't. We still got to figure out how many red marbles there were. There were 2 times as many as the black marbles, so 2 times 31, bam, 62 reds. And then we had 3 times as many, and that would be 93 perverted purples.
Just so you know, we have limited space, so.
Yeah, that's good. So let's finish writing the story, okay? Yeah, we're not finished quite yet. All right. So there are 31 black marbles. What do we got? 56 reds.
How many?
62 reds. 62 red. And 93. You guys okay back there? No. 93 of those ones, marbles. So the red is 2 times m. We don't know what m is. It didn't tell us what m represents. So we kind of had to make one up. So we just said m is the number of black marbles. If you wanted it to be green or orange or light pink or dark pink, which is more like a crimson color, that's fine too. Well, there's all of that one. So this one has 4 different expressions and then 1 equation. That means we're going to need 5 different sentences just to get through the first part. Okay, that'll make up the story. And we can see down right here in the equation that we've got this E garbage, which is represented by E, which is Elizabeth's age now. So the question will include something about that person's age. And we compare Zach, Gail, and Bob's age to Liz's or Eliz's. Eli, whatever. Okay. All right. So let's start with. We can start with a question. It doesn't really matter up in count. But Liz's age. Oh, what is Liz's age? That's what the question should be. What is Liz's age? All right, then we got old Zachary. Zach. What? Oh, not what. What is Zach's age? Zach is, well, it's S. No, it's E plus minus? What the heck is that? Minus 7?
Zach is
All right, so Zach is, that's very good, 7 years younger than Liz. Bam. And then we got Gail, who is E plus 4 rather.
Gail is 4 years
So
old.
Gail is 4 years older than Liz. Yes. And then we got old Pap. Let's get one for Pap. Pap is twice Liz's age. Bam. And then finally one for the equation. The equation E, which is Elizabeth, plus E minus 7, that's Zach, plus Gail's, which is E plus 4, plus 2E, which is Bab. So, we'll write the equation up in here. The sum of their ages, because it's just adding all the time. The sum of their ages is, how much is it? 82. 82 years. Yes. All right, now that we have these, we're ready to solve. No, there is they are. There is possession, they own it. Okay. So, some of you guys may be helped if we show 1 in front of the 2 sets of parentheses. But it doesn't matter when we distribute that. We get E plus E minus 7 plus E plus 4 plus 2 of these E's. And that would equal 82. So when I combine my E's, 1, 2, 3, 4, 5 E's. I got 5 E's. Then I got negative 7 plus 4, which would be negative 3. This all equals 82, which is very nice. Because when we add 3 to both sides, like these, we get 5E equals 85. So, to solve, we will divide both sides by 5. And that shows us that E, which is Elizabeth's age, is 17. So the next thing we need to do is write that out as a sentence. So Liz is 17 years. Then we got Zach, who is 7 years younger than Liz. So he is 10 years. Then we got Gail, who is 4 years older. So she is 21 years old. Okay, well, frankly, I don't care either way. So Bab is 2 times Liz's age. 17 times 2, bam, 34 years old. And that solves the problem right here. We've created the story, we've created a question, and we have the answers. That is all we needed. A is the measure of angle A. Then we got A plus 20 is the measure of angle B. And A minus 10 is the measure of angle C. So in at these, we got 3 sentences just right there. But then we also have the equation, which will require a fourth sentence for us to write. Of course, we like writing those sentences, so hopefully it's not too bad. All right, let's go ahead and write the sentence for A. Right here. Well, this one is our unknown, and it's in all the other equations, so this should be the question part of it, right? Excellent. What? Oh, I should use the right color on this one. What is the measurement of angle A? Question mark. All right, well, that takes us to angle B, which is right here, right? Now, again, this is in relation to angle A, but once again, we need to know how to word this garbage. So what would you guys write?
Angle B is A plus 20.
Yeah. Put angle A plus 20. All right, that takes care of that one. What about the measure of angle C, which is shown right here? Let's go and write this one in. What do you guys got for that one? Yeah?
Angle C, angle A plus 20.
That works. Well, that was angle B.
What?
So we just what you did there was angle B. We're looking at angle C there, circled in the green there, right? Yeah?
Angle C is 10 less than angle A.
That is excellent. 10 less than angle A. Bam. So that takes care of angle C. Now I put that question in the beginning, but we could put it at the end as well of all this stuff. So let's look now at the equation. Right here. Something we should notice. We got A, and then we got A plus 20, and then we got A minus 10. So that's all three of the angles, and we should include that somewhere in the wording for the equation. How would you guys word that? Because there's lots of different ways we could do this one. Well, they're all being added together, so I could say the sum. The sum of the angles is, what was it, 180 degrees. 180 degrees. Bam. So that's my word problem for these. And once again, it doesn't matter if I took this and moved it down right here, because we could specify all those. Angle B is angle A plus 20, C, the sum, and then put the question at the end. That doesn't matter to me as long as we get all the sentences in there. Because now we need to solve that equation, so let's go ahead and get to that. So I'm going to combine all the A's, and this is 1, 2, 3 A's. But then we got this plus 20 and then minus 10, which combine to give us plus 10. And of course this should equal 180. So we got 180. Let's subtract 10 from both sides so that we get the A's by themselves. 3A equals 170. Oh, that's not going to turn out very pretty. But that's okay. Let's divide both sides by 3. And we get A equals, I'm just going to make that 170 thirds. The decimal would be pretty ugly. And the mixed numbers are no good. No mixed numbers. Alright, now we should label this. This is in degrees right here. And you can put it in parentheses. That's not really important to me. But we do need to label it. Whether you write the word out degrees or show the degrees like these, either way will work. But I'm going to write this in here now as part of our story. Angle A is, what was it, 270? No,
170.
170 thirds degrees. Well, that's not all of our unknowns, so we do need to find the rest of this garbage, including angle B. Well, angle B is angle A plus 20, so that would be 170 thirds plus the 20, right? Well, 20 is not going to work because when we add fractions, we need common denominators. So we'll change this stuff. 20 will be now 60 thirds. And this gives us 230 thirds in degrees. And we'll write that in now. Angle B is 230 thirds degrees. Now, yes, of course, we could be finding the decimals to these, right? And it may look even prettier when we're writing it or typing it in like I am. But they're a little bit more difficult to work with, especially since these ones repeat. Well, let's look for the measure of angle C now. So that's going to be the 170 thirds. But now we're going to minus 10 out of that, right? Well, we can't subtract unless we get common denominators. So let's make that 10 30 thirds. And that would give us 140 thirds. And again, that's in degrees as well. So we'll write that in. Angle C is 140 thirds degrees. Bam. Well, that was a lot of writing. Maybe you guys can do that faster on your own, but that's the explanation of it all. Which is pretty nice. It's very colorful. All right, well, this is pretty taxing. Here's what we will do. We'll just solve an equation. Bam. Let's make one up.
This is our
There it is. This one is a nice problem to help you guys take a break. Let's just add a little bit to the problem, okay? You guys want something more on this? Or? I don't know. I didn't really put many negatives in this. One more minute. Let's just keep working on it and then catch up with us, all right? Right now, we got to distribute this 4 into this set of parentheses, giving us 8x minus 28. Now, we didn't do anything with the rest of it, so it stays the same. All right, now well, actually, the only 2 people I saw doing this were doing the switch and stay game, which I will not do because no one else knows about it.
What do I do?
I know. And it still works, okay? So, right here, I've got these 3x's and these negative 4x's, which would give us a negative 1x right here. The positive 23 doesn't have anything to combine with, so it's just plus 23. Now, this should equal the other side, and we're, again, looking to combine like terms. 10 and negative 28 combine to be negative 18. We got negative 8 and positive 8, which, well, these actually just cancel out. So we don't even need that plus 0 right there. We just have this equation, which now is a lot easier to solve, maybe, hopefully. Right account? Very good. Let's subtract 23 from both sides. And this gives us a negative 1x equals negative 41, right? Well,
But you have to divide.
yeah, we don't want negative 1x, we want positive 1x. So we'll divide both sides by negative 1. And we get x equals
I
41.
got that. But I didn't get this.
Here we have some given info. C is the cost of a shirt, and then we got 0.25C, which is 25% of the cost of the shirt. But down here, it shows that it's being taken off, the 25% is. So this should be some kind of discount when we describe it in the word problem. So we don't really need to describe C and 0.25C. That should just be incorporated into the words for the story problem. So let's go ahead and write that in right here. So, a shirt discounted at 25%, is, and that would be what it equals, $28.80, $28.80. The next part we got to do is write the question for these. What is the cost of the shirt. And of course, we're looking for the cost of the shirt because that's what we started with, C, and the C equals the cost of the shirt. So we just got to figure this garbage out. Let's get on with it. That's a 1C minus 0.25C. When we combine it, these, we get 0.75 C's. This equals $28.80. So from here, I'll divide both sides by 75.75. We'll get more into percents, decimals, and fractions later on. 0.75 divided by 0.75, that's a Juan. So that's good. We got the cost of the shirt, which is $28.80 divided by 0.75. I'm going to need a calculator for this one. Bam, that's it. $38.40. So we'll write that in after we wrote the problem right account. The cost of the shirt is $38.40. Alright, here's the given information. M is the height of a maple tree. 0.15 M is 15% of the height of the maple tree. That's pretty good because they gave us a lot of information right there, which means that we don't really need to do a ton of work. So we got M, 0.15 M. We'll do more decimal stuff later on. And then we got the equation. So we should get 3 sentences out of this thing. Let's go ahead and plug one in. Starting with M, which is the height of the maple tree. So that would be the question because M is incorporated into the equation and the 15% stuff. What is the height of the maple tree? Very good. Question mark. Bam. What about this 15% stuff of the height? Well, I'm trying to think if we really need a sentence for that part because it's just in the equation. So actually, I'm going to skip that garbage, which is pretty nice. Let's just move on to the equation. Well, just make sure you don't get it wrong, okay? Well, we got M is the height of the maple tree. Then we got, it's being added. And if we said this in words, we got the height of the maple tree plus 15% of the height, which is 97.75 feet. So let's specify these in the words up and count. So what that means is that the tree is grown because we're adding that height. The tree has grown 15%. Where's my percent sign? Bam, I found it. The tree has grown 15% and is now 97.75 feet. And then, of course, we have the question up in count, right? Maybe more helpful to move this down right count. A tree or maple tree has grown 15% and is now 97.75 feet. What is the height of the maple tree? You could say, what is the original height?
When I added 2 M's, would it be 1.15?
So, this one with all the decimals may require calculator inspection.
Yeah. So to start, you want to do M plus M. Well, M plus 0.15 M is 1.15. And then M. I added an M to the other M.
That was a 1 M right there, right? Plus the 0.15 M?
Equals 97.75. So I want to get that by itself, so I divide it. I have to divide it over here, and that equals 85. The height of the maple tree equals 85 feet.
Bam. Excellent. Bam, there it is. Yeah, just keep in mind I'm a math guy, not an English guy. So yeah, if some of the wording here does not make sense in your brain, it's because I'm a math guy, not an English guy. Right? Past tense, future tense, nouns, verbs, pronouns, proverbs,
All that crap. How do you know?
adjectives,
How do you know
adjectives,
everything if you're not
whatever, okay? Just, I'm more concerned about your ability to write and solve those equations. But it is good to know how to look at these and word them in context as well. Here we got z, which is the length of a side of a triangle. And then we got 2z, which is the length of the second side of a triangle. And 2z plus 3 is the length of the third side of a triangle. And then we got the equation, which is the length of the side plus the length of the second and third sides equals 73 centimeters. So that should be pretty easy to write a sentence about. Well, let's go and write sentences for all of these. And since there's 4 parts, we should have 4 sentences. Up and count. So, the first part, z equals the length of a side of a triangle. Find the lengths, we'll just include all of them, the lengths of the sides of a triangle. There we go. Now that's not a question, it's more of a statement, but it answers kind of the question. It's like Jeopardy, you got to answer in the form of a question. Well, we'll include the rest of this stuff, like we got the length of the second side, which is 2 times the z. So we could just say that the second side, oh, I don't want that garbage. That's better. The second side is twice the length of the side. Okay, that's good. That should work out pretty good. Then we got the length of the third side. The third side is 3 more than twice the length of the side. And then for the equation, the sum of the sides is, how much was it? 73 centimeters. 73 centimeters. All right, so we have all that information in our story now. All we got to do is solve the equation, and then we'll have to figure out the lengths of the other 2 sides as well. So right here, combining my z's, I got 1 z right here. And yes, we don't really need that set of parentheses because it's like distributing a 1 right here. So we don't need that garbage. On the other hand, we do need the rest of this garbage. We got 1z plus 2z's plus these other 2z's. They combine to be 5z's. Plus a 3 equals 73. Now, we'll subtract 3 from both sides. And we got 5z equals 70 centimeters. And then we'll divide both sides by 5. And we find that z, the length of a side, is 14 centimeters. Well, that's the length of that side. Let's look at the length of the other side, which was 2z. And right there we can see that z is 14 centimeter. So I'll replace z with 14. And when I solve these, 2 times 14, bam, 28 centimeter. Then we have the other side, which is 2z plus a 3. But again, we're going to replace z with 14 right there. So that'll be 14. And this is plus a 3. So 2 times 14 is 28. Plus 3, bam, 31 centimeters. So that allows us, there's a centimeters right there. So this allows us to write in the rest of this stuff. The shortest side is 14 centimeters. The longest side is 31 centimeters. And the other side is 28 centimeters. Bam. I'll move that down a little bit right here. Alright, given this information, the price of a pair of socks is S. 5S minus 1 is the price of a pair of socks. What the heck? Shoes, yeah, sorry.
It's shut.
Reading, sorry, see what I mean? Well, the equation is 3S plus 2 times 5S minus 1 equals 5650. So this one has distribution. So we have to be careful with what that represents and how to represent it in words as well. Alright, let's start with the sentences. First, the sentence for the price of a pair of socks. So let's go ahead and write this one up in here. This one is S, it's just S. So that should be our question. What is the price? I'm using the wrong color.
Do you like my shirt, Mr. Sal?
It looks like, I don't know, sewage.
He
Price
likes this one.
of a pair. I do, yeah, actually. That one looks like the sweater of a winter, actually. The price of a pair, I need to finish this, by the way, of socks. Oh, not 6, what the heck? Socks. There we go. What is the price of a pair of socks? That's just the S part right there. Then we get into this 5S minus 1. And that's a pair of shoes, so let's go and word that one up in here. And this one we will do in purple. So, I got a pair of shoes. A pair of shoes is, we'll say $1 less. Actually, I'll label that $1 less than 5 times the cost of socks.
Okay.
Bam. Alright, let's look at this equation because this one is different right here. So let's go and write our sentences for these. But let's look first. See how we got 3 S's right here? So that's 3 times S. So if we just remember what multiplication is, this should make sense. That means that we will purchase 3 pairs of socks. And in addition to that, it's 2 times the 5x minus 1 in parentheses, which means we're going to get 2 sets of shoes. And 2 sets of shoes is that price, which we have up there, $56.50. Bam. There's our sentences. We can't really just say that the price of a pair of socks and shoes is $56.50 because it shows 3 pairs of socks and 2 pairs of shoes. We do need to specify that in our sentence. Alright, so let's write, or solve this equation rather. Distribute the 2 into the parentheses, that gives me 10 S's minus a 2, and of course we got this 3S in the front, plus that 10S equals $56.50. And to solve with these, we can combine our S's to get 13 of them, 13 socks, minus the 2 equals $56.50. Well, from right here, we'll add 2 to both sides. And so we got $58.50 equals 13 pairs of socks. Well, now that we know how much 13 pairs of socks would be, we'll just divide that by 13. And we find that a pair of socks is, I gotta use a calculator for this one, $4.50. Now that's just a pair of socks. A pair of socks is, what was it, $4.50?
Yeah.
Thank you. $4.50. And then we got that pair of shoes as well. Well, that was 5 times that stuff. So that'd be $22.50 minus the $1, $21.50, right? So a pair of shoes is $21.50. Bam, that's it. That looks really good. So again, we got these 3 points and then the equation. That's going to be 4 sentences just to start off with. G is Gordon's allowance. Chris's allowance we can see is twice Gordon's, but then minus 1. And then Drew's allowance is 0.5 G. That'd be half of Gordon's. So we'll just write those in as sentences. Let's start with old Gordy's. Gordy's going to start with his allowance. And that's the number that we're actually going to find. So how much is Gordy's allowance? Question. Okay. Well, what about the next one? Chris's allowance is twice Gordy's, but then minus 1. So Chris makes $1 less than twice Gordy's allowance. And then we got Drew's, who makes half of the allowance. Half the allowance of Gordy's. Bam. Well, then we need the equation, which we can see is adding Gordy's, Chris's, and Drew's allowance, which is $51.50. So we'll just write this in up in here. The sum of their allowance is $51.50. Bam. So this makes up the word problem as we have it. Now we got to just solve this thing, okay? All right. Again, when we solve this equation, we should have Gordy's allowance. So we'll combine all the G's. 1G plus 2G plus 0.5G would be 3.5G. Now we got this minus 1 equals 51.50. And to solve with these, we would add 1 to both sides. Now we got 3.5G equals 52.50. And then finally, we would divide both sides by 350, 3.5. And we get Gordy's allowance, which I'm going to have to use a calculator for this one. So Gordy's going to make a good old-fashioned $15. Then we got the next guy, I forget his name, but it was 2G plus 1. And we know Gordy's now is $15. So, well, that was plus, minus 1. Yeah, sorry, there's a minus 1. So 2 times 15, then minus a 1. When we solve with these, we get 30 minus 1. And so we can see that that dude, he makes $29 in allowance. Next up is the last guy, and his was half of G, so 0.5 at G. And we'll replace G with Gordy's allowance, which was $15. And half of 15 is 7.5. So he makes $7.50. So we just need to write these in sentences with the rest of our problem. No. Yes, you will.
No, darn it.
All right. Where was I at? Oh, yeah. Gordy will make $15 in allowance. Who was the next guy? Eric? Chris, thank you. I was close. I was pretty close. Chris will make $29. And then we got Drew. Drew will make $7.50. Yeah. And that is the end of that one. Number 12. You'll see. All right, X is the length of that purple ribbon. 2x plus 3 is the length of the red ribbon, and 3x minus 1 is the length of the green ribbons. And then we can see down here at the bottom that they just added them all together, and they were 92 inches right here. So, we'll solve these, but first we should write our word problem. So first off, let's find the length of the perforated purple ribbon. That'd be good. Alright, and the length of the red ribbon is 2 times the length of the perverted purple one, but 3 more. So 3 more than twice the length of the perverted purple one ribbon. Alright, that's the red. Next up is the green. The green ribbon is 1 less than 3 times the length of the perverted purple ribbon. And then finally for the equation, the sum of the lengths is 92, what was it, inches? 92 inches. Well, that completes that part. That's pretty good. All right, let's solve the equation then. All right, solving at these. We got 1x, and then these 2x's and these 3x's, which combine to be 6x's. Then we got this 3 minus a 1 up in here, which is a positive 2. This should equal 92. And this is a very nice one, because when we subtract the 2, we get 90 up in here, which equals our 6x, because these zero out. Dividing by 6 on both sides, we see that x equals 15. And that was in inches, so we'll need to label that. So this was for the perverted purples. Let's figure it out for the reds, which was 2x plus a 3. So 2 times 15 plus a 3, bam. That would be 33 inches. And then we had the greens, right, which was 3x minus a 1. So that's 3 times 15 minus a 1, which is 44 inches. Well, we just need to write these in words now for the sentences above. Alright, the perverted purple ribbon is 15 inch. The red is 33 inch. And the green, anything with green. Green is 44 inch. Bam. That's it. Let me move this down a little bit. Here's the given information. Right out here, we got x. This is our x. We got the y. Not the y. It's a 1/5 x. That's 1/5 of the money Jamie made. We got 2/5 of the money Jamie made. And then finally the equation down here. So we will need 4 sentences. 4 very, 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 very nice sentences. Starting with the amount of money Jamie earned. Or is it Jaime? I don't know. Jamie, that's the question one, right? So how much money did Jaime or Jamie work? There's that one. Well, the next two sentences, actually, they're already written out for us. So they're just kind of involved in the equation right there. So we'll just write that out for the equation up in here. So the equation tells us that 1/5, we could include other people, I guess, on this. That'd just be really weird because they didn't give us any names. Let's do that anyways because it should hopefully make more sense. You know what? I guess it would still be kind of included though, because we're gonna have to make something up for this because it doesn't really specify what the heck is going on right here. So we could say that Jamie's buddy John makes 1/5 of what Jamie makes. And then we got that one in green right here. That's 2/5. So we should specify these. But we do need to make up a name for that person as well. So we'll stick with the J theme. Jones.
Jacob.
Jones. Jones is good. Jones
Jacob.
makes 2/5 of what? Yeah, what, you can put it in there. Jones makes 2/5 of what Jamie makes. And then, of course, we got that one there at the end, up in here. So, together, John and Jones make $165. Bam, there's a good sentence. You make a good point there. We didn't really need to write those all out. The purple and the green one. Because we could have included it in the equation, but we didn't really know what that was, and right now we've specified that it's how much some other person makes, okay? Well, let's go and solve this equation. So yes, this is a little bit different, and this is good because we have common denominators for both x's, so we can just combine these two. 1/5 plus 2/5 would be 3/5 times the x. This should equal 165. Now you guys may divide by the fraction to make this kind of a one-stepper. I like to get rid of the fraction by multiplying both sides by 5. So these cancel out. I'm left with the 3x equals 5 times 165. 825. Thank you. And then radical would divide both sides by 3. And we find that x equals that's a 2 and a 4. 275? I do that wrong. Oh yeah, because it's 22. 275. Thank you. Well, x was how much Jamie made. So to figure out how much, I think it was John first, right? John makes 3/5 of what Jamie makes. So 3/5 times the 275 would be 55, and the 3, 150, 165. So, oh yeah, 1/5. I'm looking at the wrong one there. Let's look at 1/5. That'd be better. 1/5. That's $55 right there. And then we got the other buddy, John, who was 2/5 of the 275, which should be $110 for these guys. All right, so let's write these out in sentences. Jaime makes, what was it, 275? 275. And then we can move on to old Johnny. Johnny, he gonna make, John makes, what was it, $55? And then we got Jones. Jones makes $110, right? See how I'm trying to teach right here? Don't, gosh. All right. Well, that's it. That looks pretty